Dark questions, chilling answers. Welcome to Shadow Theories. Today we ask the question, can we nuke an asteroid to save the Earth? Let's explore this topic together. Right now, as you watch this video, thousands of asteroids are silently drifting through the void of space. Some no bigger than a house, others the size of mountains. Most are harmless, but it only takes one rock traveling at tens of thousands of miles per hour to end life on Earth as we know it. So here is the question. If we ever discovered a killer asteroid on a collision course with Earth, could we nuke it to save ourselves? Or would we only make things worse? A rock the size of just one city block could level an entire state. An asteroid half a mile wide that would cause global devastation, tsunamis, earthquakes, and a firestorm across continents. 65 million years ago, an asteroid only 6 miles wide wiped out the dinosaurs. Today, NASA tracks over 30,000 near-Earth objects. But here is the nightmare. We have only mapped a fraction of what is really out there. One could already be on its way, and we might not see it until it's too late. So what's our plan? Some scientists say the only weapon powerful enough to stop a world-ending asteroid is a nuclear warhead. The idea is simple. Detonate a nuke near the asteroid, vaporizing part of its surface. The blast could push it off course just enough to miss Earth. But here's the problem. Asteroids are not solid rocks. Many are giant rubble piles held together loosely by gravity. A nuke might not deflect it. It might just shatter it into countless deadly fragments, turning one bullet into a shotgun blast aimed directly at Earth. This isn't just science fiction. In 2022, NASA launched the DART mission, the first real test of planetary defense. A spacecraft slammed into an asteroid called Dimorphos and successfully nudged it off course. But here's the chilling truth. That was just a tiny test. What works on a harmless rock the size of a stadium may not work on a mountain-sized asteroid heading straight for us. In the end, nuclear weapons might be our last desperate option. But imagine it. The world unites. Thousands of missiles are launched. A nuclear warhead detonates in the silent darkness of space. One of two things happens. Best case, the asteroid shifts slightly, missing Earth by thousands of miles, and humanity survives. Worst case, the blast fractures the asteroid, sending a rain of fiery debris hurtling toward Earth. Instead of one impact, we face hundreds, each strike igniting fires, leveling cities, and blacking out the skies with ash. We may survive the first explosion, only to die slowly in the freezing darkness of a nuclear winter. So what are our real options? Scientists have proposed kinetic impactors, slamming heavy spacecraft into an asteroid to push it off course. Gravity tractors, parking a spacecraft nearby to slowly pull it with gravity. Solar sails and lasers, using energy to nudge it away over decades. But all of these require time. If we detect the asteroid decades before impact, we might have a chance. If we see it only years or months away, the nuclear option may be the only card we have left to play. In the end, the question isn't just, Can we nuke an asteroid? Will we even know it's coming in time? Because right now, we are flying blind. At any moment, a silent killer could be racing toward us. And the only thing standing between survival and extinction might be a single launch button. So tell me, if you were in charge, would you push it? You wouldn't have to look far to find plenty of fictional accounts of nuclear weapons being used against asteroids. From Armageddon to the recent Don't Look Up, Hollywood has certainly explored this idea quite a bit. There's always some sort of wild disaster averted at the last minute. But there are also some terrifying lessons to learn from these stories. For one thing, we generally do know when an asteroid is going to hit the Earth. There are plenty of examples of this. For example, the Chelyabinsk meteor that exploded over Russia in 2013 wasn't a huge space rock, but it was big enough to wreak havoc on the region. And while many people were injured by the flying glass from the windows that were blown out, the damage overall was minor. And because we had advanced warning of the impact, we could collect data and samples from the event afterwards. But how does the scenario change if we're faced with a much larger object? Let's go back to the dinos. Scientists believe that the asteroid or comet that led to their extinction was between 6 to 9 miles wide. If something like that was hurtling towards us, we'd definitely need more than one nuclear weapon. But even still, there's a theory that the asteroid itself was only the beginning. There were massive volcanic eruptions happening around the same time. The Deccan Traps eruptions in India released enormous amounts of carbon dioxide and sulfur dioxide into the atmosphere. These gases blocked sunlight and led to a cooling effect, which likely exacerbated the effects of the asteroid impact. The moral of the story is that using nukes against a large incoming asteroid could be a dangerous gamble, even if you can destroy the main object. There's no guarantee that you'll prevent smaller fragments from making it to the ground. But what if we had more time? Let's say that we're aware of an asteroid hurtling toward the Earth decades in advance. Well, then we have some other option. We talked about kinetic impactors earlier, but another intriguing method is known as a solar sail. The idea is to park a spacecraft near the asteroid and use large sails to reflect sunlight. Over time, this would build up enough momentum to move the asteroid off its current trajectory. The main flaw in this approach is that it would take around 200 years to accomplish this. But the advantage is that it wouldn't involve blowing up anything. On the other hand, lasers seem like the most obvious solution to this problem. The concept of laser deflection has been studied since the early days of the space program. NASA even came up with a design for an all-powerful space-based laser capable of destroying an asteroid in less than 10 minutes. Unfortunately, this system required a power supply so large that it never got off the drawing board. But with new technologies emerging every day, it's entirely possible that a laser-based system could become a reality in the future. However, even if we do develop the tech, there are still risks to consider. An asteroid that's covered in dust or ice could reflect the lasers back at Earth. This could cause serious damage in worst-case scenarios. Not to mention that setting up a laser system in space would be extremely expensive. But what if we're running out of time and none of these methods are feasible, then we might need to go back to basics and simply blow the asteroid to smithereens. But again, it's not quite as easy as Bruce Willis made it look in the movie. The first problem is figuring out where to hit the asteroid. Scientists would need to know the exact composition of the object in order to calculate how an explosion would affect its shape and trajectory. Second, we'd need to figure out what kind of explosive would be the most effective. It might not be a good idea to use a nuclear weapon, unless we want to risk creating a cloud of radioactive debris. We might be better off using conventional explosives, but detonating those inside of an asteroid could lead to unexpected results. For example, a nuke could theoretically ignite certain elements within the asteroid, causing a chain reaction. The only way to get a clear answer would be to conduct tests, and the best place to do that would be at a remote site in New Mexico. In the meantime, we'll keep searching the skies for any potential threats. Thanks to telescopes and satellites, we've been able to map the paths of millions of asteroids. The chances of a large one hitting the Earth anytime soon are very low. But remember that there are thousands of objects out there that we haven't yet detected. The more we explore, the more we find. And the truth is that we're probably only scratching the surface. If you enjoyed this video, please subscribe to our channel and stay tuned for more stories. And if you want to support our channel, be sure to check out our Patreon. And with your support, we can continue to bring you the most exciting and thought-provoking shadow theories. Also, be sure to check out some of our other videos like What if 3i Atlas isn't just a comet, but an alien spacecraft? Or Why hasn't NASA discovered aliens yet?